Welcome to SQL Dan, and in today's episode I'm going to talk about finding the highest record. It seems like a really simple concept, but it's trickier in SQL than it might seem. So welcome in, and as I mentioned, today's episode I'm going to look at finding the highest value. And to demonstrate this, I have a data set which consists of the 50 states and the highest mountain in each one of those 50 states. And we're going to answer a couple of questions like, which state has the highest mountain, and what is the name of that mountain? And the analog for this type of analysis might be things that you would do very commonly, such as, which store has the highest sales? Which student had the highest grade on the test? Which day had the highest temperature this year? All of these can be applied to answer those types of questions. Now, doing this kind of analysis is actually a two-step process. The first thing that you have to do is find the highest value, and then you have to read the values from that. So just demonstrating that with a look at this table, I would have to scan through this elevation column and find the highest value. Okay, and in this case, I already know that the highest value is this 20,320. And then I have to read the other values or the other records that are associated with that. Now, probably on the very first day of learning SQL, most of us learned how to get the maximum value. And it's simply to use the max function. So if I say right here, select the max elevation from state high points, it will find the highest value that's in that list. And in this case, that value is 20,320. But what I don't know is anything about that record. As I mentioned earlier, the questions that I had were, well, what state is that, or what's the name of the mountain? But simply by using the max, I can't get that information. So typically what I would have to do, using the two-step process, is now I have to query the table again and find the record where the elevation equals that amount, that 20,320. So when I run this query, supplying the highest value in the where clause, I can now find the state and the name of the mountain, Denali. And so the way that this is typically addressed in SQL, rather than doing two different queries, is to combine these two queries like this. Copy this down, and then I'll replace the max down in here. So instead of saying where elevation equals 20,320, I can put that other query in as a subquery and replace it like that. So when I run this, I now get the record that has the highest value, and I can also get the other attributes of that record. So I can tell you what state and what the high point is, simply by replacing that hard-coded highest value with a query that derives the highest value. But you can see one of the problems with this query is that we're hitting the table twice. First of all, to get the maximum value, and secondly, to get the other information about that value. Now, in a table that only has 50 records like this, that's not a problem. But what if the table has hundreds of thousands of records, or even millions of records? You can see that this could become a performance problem fairly quickly. So what I'd like to do is to examine a few different ways that we could get the same information while only hitting the table once. So in some other videos, I've mentioned the concept of analytic functions, and if you don't know how those work, you might want to go and check out some of my other videos. But let me just demonstrate very quickly so that you can see how this is going to come together. Again, here's just my basic query of the table, and I'm going to add one field in here, which is the max elevation over, and then some empty parentheses. So this is an analytic function which will derive the highest value out of the entire data set and return it on each of the records. And we can see that in the fourth column over there, that highest value that we've identified is now present on each of the records. And then all we have to do is test and find the record where the elevation column is equal to that highest column. Now, because of the way that analytic functions work, we can't just put this in the where clause, because typically the where clause is executed before the analytic function is executed. So the way that we get around that is to nest that inside of another query. So I'll paste it down here, and we'll just do a select star from, and then we'll put this other query inside of parentheses and do this. And just to show you here, this is returning exactly the same thing, but the key is that we still are only hitting the table one time. And so now all of this inner query will execute before the where clause in the outer query gets executed. So now we can put another where clause. In fact, let me just move this parenthesis down to make it more clear here. And now in order to reference this in the where clause, we actually have to assign an alias to this. So let's just call this maxval. Okay, and so now we can say where maxval equals elevation. And when I run this, we can see that we're now getting the one record that we were looking for. And I can tell you that Alaska is the state that has the highest mountain in it, and the name of that mountain is Denali. So that's one way to approach this with analytic functions. However, there are two different techniques, and I want to show you those because there are some use cases for those as well. So the second analytic function that I wanted to show you is the rank function. And just to make this easier, I'm going to copy this first query down. Okay, and at the moment we won't need the where clause, but we'll come back to it in just a minute. And now instead of the max function, I want to use the rank function. And the rank function doesn't include any field here inside of the parentheses, so that's always left blank. However, in the second set of parentheses, a requirement is that we include the order by, because this is going to give us a ranking of the record, and you'll see what that means in just a minute. But we have to tell it what order we want the records to appear. Okay, and I'm also going to change the alias, because again, we'll be needing that for the where clause. And I'm also, just for the sake of this query, I'm going to add an order by on here, and then we'll change that in just a second. All right, so let's run this query. And there we can see we've got all of the states returned and the other information we saw before. But over here now we have a rank column, and there are numbers from 1 to 50 in this column here. And we can see that Alaska currently is numbered 50 and Florida is numbered 1. Okay, I just wanted to put them in order by state for just a minute so you can see how it works. But now let's go ahead and order by the ranking column, and let's do a little bit of more work on it here. Now we can see I have these in order by rank from number 1 down through number 50. The problem that I have here is actually the item that's ranked number 1 is Florida, which is the one that has the lowest high elevation. So basically the highest point in Florida is only 345 feet. But I wanted to find Alaska in here, and Alaska is down here at number 50. Now I could simply I could take the where clause and I could query out where rank equals 50, like so. And Alaska is ranked number 50, so we found the record that we're looking for. The problem that I have here is that in this particular case, I know exactly how many records there are, so I know what value to put here in the where clause in order to find the highest record. But what if there were a variable number of records? What if I don't know what the highest numbered value should be? So this is not really a practical way to go about this. What I want to do instead is I want to order by elevation in descending order. So if we run this, let me take off that where clause. And now we can see we have them ordered so that the highest mountain is ranked number 1, and then it works downward from there. And Florida is number 50. So this is what we want in order to be able to find the highest record, is we want to put them in reverse order and then rank 1. Because then it doesn't matter how many records there are in the data set, always the highest record will be ranked number 1. And there we've got Alaska. So that's the second approach for how we could do this. And now let's move on to the third of the 3 analytic functions I wanted to show you, which is first value. Now for this demonstration, we don't need to nest the query because I'm not going to use a where clause. So I can just simply copy this portion of the query down And instead of the rank function, I'm going to use first value. So first value does require something inside the parentheses, unlike the rank function, and it's basically the value that you want to see. And I'll explain a little bit more about what that means in just a second here, but for the moment I'm going to put the state field in here. Okay, and I also no longer need this alias, so I'm going to remove it just to eliminate confusion. And let's run this query, and I'll explain to you what's happening here. Okay, we see that we have Alaska on each of the records. And so what this is doing is it's applying this order by that you see within the over section here. Okay, and it's using this order by to find the record that would be ranked number 1. And we already saw that when I ran the rank function, that the record with the 20,320 was ranked number 1 because it's the highest value. And so it basically identifies that record, and then it shows you a different field from that record. So in this case it says first value and then show me the state field, and so it's showing me Alaska. Now let's extend this a little bit further and let's add yet another one here. And I am going to add the high point field to get the name of the mountain. I'll run it one more time. And now we can see, okay, we're getting all of these fields, and we're also getting the name of the state, Alaska, and the name of the high point. Now we don't need these other ones anymore, and so let's just execute it with only these two so we can get just those two values. And now we have one step left. Now you might notice here that we're getting still 50 records, but all 50 records have exactly the same value. And the reason that this is happening is because an analytic function never changes the number of records returned. It simply executes the function and returns it on each of the records. So the last step that we would need to answer this question is to add a distinct. And here we go. We are now getting one record, and we have the name of the state with the highest mountain and the name of that mountain. So those were the three techniques that I had available to you. You could use the max with over, you could use the rank with over, or you could use the first value with over. Now before I break, one more caution to you, and that is to be careful for ties in the data. If you have two records that both have the same value, you could end up with inconsistent results. And so I'll have another video later on how to deal with things like that, and a couple of other ranking functions that handle ties, and also a couple of other ranking functions that handle ties a little bit more gracefully. But I'll leave that for the scope of this video. This is SQL Dan saying thank you for watching.